Hi guys! So we will discuss the types of tests. I'm Chanel.
I'm Chloe.
And I'm Anthony Chala.
So we did 3 different types of tests, and the first one is one sample t-test.
So our question is, a random sample of 49 medical doctors in LA showed that they worked an average of 53.1 hours or week with a standard deviation of 7.2 hours or week. If California average is 60 hours or week, does this give evidence that the LA doctors work significantly less than the rest of California? So, the null hypothesis is that the mu is equal to 60, and the alternative hypothesis is that the mu is less than 60, and alpha level is 0.05. And these are our requirements. Our independence, it does not affect each other's time. It is randomly selected. And we assume that they are less than 10% of the population's work average, and it's nearly normal. Since all of the conditions have been met, we will now perform a one-sample t-test. So we have collected all the data, and our standard error is 7.2 over the square root of 49. And our t-score is negative 6.708. And our p-value is 0.00000000103. With a p-value of 0.00000000103, we reject the null hypothesis as being that doctors at LA work significantly less than California.
Shoe manufacturer has developed a new running shoe that portably enables one to run faster. 8 adults participated in an experiment in which each ran a mile with regular track shoes and then ran a mile the next day with the new shoes. The running times in seconds are below. The question is there evidence that the new shoes works better? This is how we put it in the calculator. L1 is the new shoes, and L2 is the track shoes, and L3 is the difference between the new shoes and the track shoes. So our null hypothesis is that the mu's difference is equals to 0, and the alternative hypothesis is that the mu's difference is less than 0, and our alpha level is set at 0.05. Assumptions and conditions. The data are paired, and it is not specified if it's randomly selected. Each type of shoes doesn't affect each other, therefore they are independent. Assume that 8 people are less than 10% of all the persons that will try the new shoes. Assume that the population is normal, and it is nearly normal according to our histogram. It is a little bit skewed to the right. Since not all the conditions have been met, we'll still perform a paired t-test. Our n is 8, our standard deviation is 4.438, and our mean is negative 3.65. The standard error is approximately 12.553, and our t-score is negative 2.210. This our p-value is calculated at 0.027. With this p-value, we reject the null hypothesis, being that it proves that the new shoes doesn't work better than the track shoes.
So now let's proceed to one proportion z-test. The question is the proportion of the Hershey's chocolates equally distributed? So these are my data, and the null hypothesis is 0.25, and the alternative hypothesis is p is greater than 0.25, and the alpha level is set to 0.05. And these are the conditions. The chocolates were randomly chosen at the store, and 66 chocolates are just a small proportion of a larger number of all the Hershey chocolates in the world. The success failure is that we'd expect that the success is 14.982, which the dark chocolates, and the failure is 51.018, which are the non-dark chocolates, and both are at least 10. And now, since all the conditions have been met, we will now perform a one proportion z-test. So the p-hat is equals to 15 over 66, which is equals to 0.227, and the standard deviation is the square root of 0.25 times 0.75 all over 66, which is equals to 0.0533. And now we will perform the z-test, which is 0.227 minus 0.25 all over 0.0533, which is equals to negative 0.4264. So we did the calculation and we have the p-value of 0.665. So with a p-value of 0.665, we fail to reject the null hypothesis, given that there is no enough evidence that the chocolates are not equally distributed. So that is it, guys. Thank you for watching.